are designed to connect your body through your sock to static control flooring. There are basically two types of shoe grounders: sole grounders and heel straps. Sole grounders are the most effective of the two since they cover a large portion of the sole of the shoe. Heel straps only connect to the static control flooring from the heel of your shoe. Shoe grounders are very effective for stand-up operations, especially if you need to move around a lot. This eliminates the problem of a long cord from the wrist strap. Most companies require the use of two shoe grounders for standing activities and a wrist strap for seated operations. The grounding strip should be placed between your sock and the inside of the shoe in such a way that you will be standing on the strip. There is enough moisture in your sock to provide a complete electrical connection from your body to ground. Visitors to ESD protected areas may be provided with disposable shoe grounders, which are worn once, then discarded. There are other ways of passing charges harmlessly to the ground. Static control footwear function like shoe grounders in that they provide a conductive path from your body through your sock and shoe to static control flooring. When testing shoe grounders, place the foot with the strap on the metal plate and press the test button. The pass light indicates that the device is functioning properly. If wearing shoe grounders on both feet, test each foot individually. Testing both feet at the same time will not indicate a failure unless both straps fail. Static control footwear is tested the same way. As with shoe grounders, each foot should be tested individually. There are, however, some testers that have the capability of testing both feet at the same time. Shoe grounders and static control footwear should be tested at regular intervals to make sure they're working properly. Again, your company will let you know where and how often you should do this. If you experience any problem with personal grounding devices, let your supervisor know immediately. Now let's discuss the use of continuous or constant monitoring of wrist straps. The sad truth is that wrist straps typically don't fail just before you test them. In fact, they are more likely to fail while you're working with ESD-sensitive devices. The solution to this problem is the use of continuous monitoring. The continuous monitoring device contains an alarm that immediately notifies an operator when the wrist strap does not comply. Continuous monitors do not work for shoe grounders or static control footwear. Let's turn our attention to static control smocks. Static control smocks may be used to suppress electrostatic fields on an operator's clothing and prevent those fields from causing field-induced ESD damage. It's important to completely button the smock so no part of your clothing is exposed. Similarly, the sleeves should never be rolled up to the point where underlying clothing is exposed. In some companies, static control smocks are not provided. Clothing made of cotton generates minimal charges because cotton is a neutral material. Clothing made from wool or polyester generates much larger charges. You should also avoid wearing loose clothing that drapes down and may come into contact with ESD-sensitive devices. Now let's take a closer look at an ESD-protected area. Inside the boundaries of this area, you are responsible for following and enforcing company policies on ESD control. One way of controlling ESD in your work area is to eliminate any non-essential insulators or non-conductive materials. Non-essential insulators are those items that are not required for the building of your products. These types of materials tend to generate and hold static charges, thereby creating electrostatic fields. When a charged object, such as these plastic safety glasses, is brought close to an ESD-sensitive device, the electric field causes charge separation in the ESD-sensitive device. If the ESD-sensitive device then comes in contact with a conductive item while exposed to the field, an ESD event occurs and the device can be damaged. Here are some examples of non-essential insulators that should be eliminated from your work area whenever possible. Process-required insulators are those items required to be used for your process and therefore cannot be eliminated. There are, however, techniques that can help to deal with these charge-generating materials. One technique is the use of an air ionizer to neutralize charges. The ionized air must be directed toward the charged item in order to neutralize any positive or negative charges that accumulate. Make sure that the air ionizer is turned on and that the airflow is directed where needed. Another method of protecting ESD-sensitive devices from process-required insulators is to arrange the workstation so that static-sensitive assemblies are no closer than 12 inches to the static-generating materials, if that's possible. It may also be helpful to apply an anti-static solution to these hand tools at regular intervals. Again, the best ESD control solution is to eliminate all non-essential materials that generate and hold static charges. In spite of all precautions, ESD-sensitive devices will sometimes become charged. Therefore, it's important that they are not allowed to discharge rapidly, since the rapid transfer of a charge to a conductive surface may cause damage. A static control material is used to eliminate those harmful discharges and may be found in various work surfaces and containers. These materials conduct electricity, but do it slowly enough to leave the ESD-sensitive device undamaged. The static dissipative work surface is most commonly used in this type of ESD control. If an ESD-sensitive device becomes charged and is placed on this surface, the charge will flow between the device and the surface at a rate that will not harm the component. On the other hand, this metal work surface is a good conductor of electricity, meaning that if the ESD-sensitive device becomes charged and is placed on this surface, the electrostatic discharge will happen too quickly and may damage the device. We've just looked at a number of ways to control ESD in our work area. ESD control works most effectively when you assume that all the components and assemblies that you handle are ESD sensitive, even when they're not. ESD sensitive devices should be properly labeled, but sometimes someone forgets. That's why it's important to get in the habit of performing all activities with ESD safe practices. Another way to control ESD in the work area is to avoid activities that generate charges. These include combing hair or touching static generating materials. Remember, don't allow anyone into an ESD protected area unless they are trained and equipped per your company's procedures. Our last section deals with protecting ESD-sensitive devices during handling, and when we transport them from one ESD-protected area to another, or from one facility to another. We've already learned how to protect these devices from the static fields and uncontrolled discharges in the work area. Whether you're performing incoming inspection, storing items in the stockroom, kitting, doing assembly operations, or testing and troubleshooting, here are some tips for the safe handling of ESD-sensitive devices. Handle components such as integrated circuits by a non-conductive portion of the body rather than the leads. The leads are the most conductive pathway for an ESD event. The body of the component is less likely to provide a pathway for an ESD zap. Place the device with the leads down on a static dissipative surface. This way, the component leads are all at the same electrical potential. And don't slide the device over any surface. Sliding can also generate static charges. When handling electronic assemblies, it's important to hold them only by the edges, minimizing contact with any conductive surface. Because components are connected, an ESD charge to one component can easily spread to others. The key point for handling is to minimize handling of ESD-sensitive items as much as possible. Now let's turn our attention to ESD protective packaging. There are two categories of ESD protective packaging: low charging and dissipative, and ESD shielding, also known as static shielding. Low charging refers to a material's ability to resist triboelectric charge generation. This material does not generate or hold a charge, but it won't protect the enclosed product from a charge that comes from another source. Static shielding packaging actually protects the ESD-sensitive device from static discharge. The charge will not be able to easily penetrate the packaging. Low charging packaging is required for the movement of ESD-sensitive items within an ESD-protected area. It is considered optional to also use static shielding packaging. However, a combination of low charging and static shielding packaging is required when transporting ESD-sensitive devices out of the ESD-protected area to another job site, whether it is inside or outside of your facility. Be aware that static shielding packaging doesn't work unless it is closed and properly sealed. Carrying a circuit board assembly on top of ESD packaging or using the ESD bag the way you'd use a pot holder are not safe practices. That's because the assembly is still exposed to ESD hazards. The point is that to achieve the full intended protection, bags or other types of packaging have to form a Faraday cage-like enclosure, meaning the product must be fully enclosed with absolutely no openings. It's also important to use clean containers that are the proper size for the device and are clearly marked for ESD-sensitive items. And use only approved packaging materials. When transporting ESD-sensitive items, use push carts or racks that are designed for ESD-sensitive devices. Again, your company will explain its policy regarding handling, storing, and transporting ESD-sensitive devices. This program has presented the details of controlling ESD during electronics assembly. First, we discussed static electricity and took a look at how poor ESD practices can affect electronic components. Then we examined the ways of controlling ESD in our work area. This included wearing and testing our ESD personal grounding equipment, removing unnecessary materials, using static dissipative materials, and avoiding activities that cause ESD. We know that the best way to control static charges is to prevent their formation whenever possible. We concluded with a discussion on the proper handling, storage, and transport of ESD-sensitive devices. ESD is everyone's responsibility. You need to wear the appropriate equipment and to follow the proper procedures for handling, storing, and transporting ESD-sensitive devices. And you need to report any problems or ESD hazards promptly. Your personal knowledge about ESD control and attention to detail can make the difference between success and failure.
I feel a surge coming on.